How to find the area of a parallelogram? Suppose we have a parallelogram. We want to find the area of this parallelogram. The trick is we have to use what we know of in order to find the area of a parallelogram. We know how to find the area of a rectangle because we can simply calculate the area by using the length times the width to calculate the area of a rectangle. So the idea is, how can I use a rectangle, my knowledge of finding the area of a rectangle, to help me to find the area of a parallelogram? The trick is, I can somehow cut the parallelogram and make it become a rectangle. And let's see how this is possible. Now, the cutting is like this. You can cut from one of the corners, draw a perpendicular line to the opposite side, and this line will separate the original parallelogram into two parts. One part will be a right-angled triangle. Now, this right-angled triangle is the part you can move around in order to help you to solve the problem. Now, I'm going to demonstrate this on the left-hand side. Now, this is the two parts separated from the original parallelogram. Now, let me move the right-angled triangle in order to turn the original parallelogram into a rectangle. And this is how it can be done. I simply put this right-angled triangle from the left to the right-hand side, and magically the original shapes turned into a rectangle. And now if I ask you how to find the area of this rectangle, then you can answer by, okay, I need the length, I need the width in order to calculate the area of the rectangle, and that is the same area as the parallelogram. So you solve the problem. Okay, but there's one more thing we need to think about is, what do we mean by the length and the width in the original parallelogram? Okay, let's compare these two graphs. Let's look at the width first. The width is actually the dotted line. The dotted line on the parallelogram. And we give a name to this kind of a dotted perpendicular line. We call it the height. Okay, what about the length? The length is made up of two parts on the graph in the graph on the left-hand side. It's made up of this part and this part. And but we can actually see that this is actually the same length as the side, one of the side of the original parallelogram. Now we give a name for this special side. We call it the base of the parallelogram. Okay, the length of the rectangle you turn it into is actually same as the base of the parallelogram. In other words, if we have a parallelogram now, we only need to measure the base and the height in order to calculate the area of the parallelogram.